Hello, everyone. How's everyone doing this morning? Are you awake? So this is Optimizing for Learning. Before I get started, I just want to thank all of the organizers, my fellow speakers, and of course, all of you in the audience for joining me today. Hi, my name's Logan, and I'm really excited to be here today. As Jason said, I gave this talk as a lightning talk last year, and Jason made the mistake of inviting me back to rant on it for 6 times the amount of time, so thank you to Jason. I go by Logan Meets World on Twitter if you want to tweet at me throughout this. Only nice things, please. This is not related to Boy Meets World, but I just like meeting people, so I'm going to be really happy to meet all you after. Shout out to the tremendously talented Emily Griffin, who made this amazingly cute avatar and several other illustrations for this talk. Give her all the credit for the visual aspects of this talk. So, about me, I work at BuzzFeed, so legally the title of this talk has to be 12 Learning Science Concepts Applied to Monitoring, and the 7th will surprise you. And because I work at BuzzFeed, I do the same thing all other BuzzFeed employees do, and I work on quizzes. So you can take this quiz that I made to find out which monitoring system is best for you. I'm joking, of course. I don't work on quizzes. At BuzzFeed, I work to ensure 2 simple things. Good things reliably don't disappear, and bad things reliably don't appear. And in that, I concentrate on the security aspects of site reliability. But none of that is what I want to talk about with you today. So let's get started with a story. I studied economics and math in college, and I wrote my senior thesis on a particular field in economics called behavioral economics. Behavioral economics marries insights from human behavior and cognitive science with statistical tools from economics. It turned out when I graduated, I was more interested in writing the code to program regressions than the regressions themselves, but this interest in cognitive science kind of remained for me. So, flash forward to my first week at my first job as an ops engineer. There was an incident with our search system, and I got to witness my very first outage. So I don't know how all of you felt during your first outage you ever witnessed, but I'll never forget staring at the plethora of graphs with reds and oranges and the occasional green, and trying to make heads or tails of it with this sense of urgency as I watched Slack chatter fly by. I was standing near a senior engineer, and I was watching his eyes fly over the same information that was incomprehensible to me, and he suddenly just whispered, "Oh, open file descriptors." And then he started typing really fast, and I had no idea what was happening, and in minutes, everything started flickering to green again. I was amazed, but to be honest, horrified by this wizardry. And I panicked that first week. I wanted to be a contributing member of my team as fast as possible, but I didn't know if I was ever going to get to that point. But then, because of my background, I recognized something in what he did, and that's expert intuition. But I had the benefit that not a lot of other junior engineers have in that moment. After my anxiety subsided, because of my background in behavioral economics, I realized something else. Expert intuition is not magic. Expert intuition is achievable. So today, I want to talk about the journey for me that followed that realization and the tools that I used to overcome my fear of incidents. I love this review that John Alsbaugh gave at Monitorama 2013 of his favorite monitoring system. He said that it was one of the most powerful, context-sensitive, incredibly adaptive, anomaly-detecting, and responding agents in the world, which is a very Alsbaugian sentiment. And he's talking, of course, about the human mind. If we're going to have a conference to talk about the most advanced monitoring and observing systems, we would be foolish to not include our minds amongst those tools. One day, we may design tools that are more powerful, but until then, we benefit greatly by improving our memories and optimizing our learning processes. So you may be thinking, well, this talk is good for less experienced engineers, but I'm already an expert. But this isn't true. Today, I'm going to share evidence-based practices for improving our ability to learn. The ability to learn is critical for all of us. When we improve our memory, we improve our ability to maintain focus and ignore the noise around us. Furthermore, I think it's beneficial to think about how we learn because our industry is constantly changing. The teams we're on are constantly changing, and we need to be able to think and learn fast. Knowing these tools can help us better design teams to be learning teams and better onboard new people. Our ability as humans to recognize when other people don't know something that we know is terrible. And so being open to learning is critical. So let's get started. I've broken this talk into 4 phases that I went through using learning and behavioral science tools to improve my memory and thus my ability to respond to incidents in my job as an ops engineer. The first is preparation. When I took that first job as an ops engineer, I had a vague understanding of the field. I had interned previously at a DevOps vendor where I had a good introduction to ops and what this DevOps thing was, but working as an operations engineer was new to me. So I set out with the first question, what do I have to learn? And that's something that I discovered about the nature of our field that you all may already know. Monitoring and incident response for complex systems requires a vast amount of experience with a vast array of tools to even get started. When I would ask people, okay, I want to be really good at this. I want to be able to respond to incidents fast. What do I need to know? They tell me, like, maybe you should look at a cloud provider. But which of the huge amount of services? They would tell me to learn continuous integration tools, to learn about networking and security protocols, to learn about terminal skills, and on and on and on, which left me feeling very much like this. Overwhelmed and pretty lost. And that's when my first tool in cognitive science really helped, which is the idea that problem solving is easier with constraints. So in math and economics, we often deal with CSPs, or constraint satisfaction problems. And these problems are a set of mathematical questions defined by objects whose state must meet certain constraints. These become useful in our cognitive toolkit as well in an area of study that cognitive scientists call constraint theory. In constraint theory, cognitive scientists posit that when we constrain our conceptual combinations, we open our brain up to a smaller set of possibilities. So say you were tasked with designing a theater. You'll probably want to start by just asking some questions about it. How big is that theater? How many people does it need to sit? Where do we need to place different pieces on the stage? Asking these questions begins to constrain the amount of possibilities that can go into that design. So I asked myself that question, okay, what do I need to fit into the room of possibilities of what it means to be an ops engineer? And my answer to that question came in the form of a helpful guidebook, the Google SRE Handbook. In section 3 on practices, there's a very helpful model called the Dickerson hierarchy of site reliability, named after Mikey Dickerson, who worked at Google. I found this to be a really helpful way of constraining what I needed to learn first. And because monitoring was at the base, I decided to tackle that first. I brought this to my manager and asked if I could be involved in building out our next generation monitoring system. I could have started anywhere in operations, but intentionally choosing an area was super helpful for me and bred a lot of creative freedom. So now that I had constrained my path for learning, where should I start? Could I just jump in and start building out a metrics pipeline? Which software should I use? Which brings me to the next really helpful model. And this is the idea that it turns out there are hierarchies of learning that provide really helpful places of where to start. My favorite is Robert Gagne's hierarchy for learning, and this is the hierarchy. So it starts with lots of signal learning and stimulus response learning, and for me this meant lots of trial and error before making associations and finally solving problems. This led me to start with proofs of concepts and building out a metrics pipeline rather than just research. This was really beneficial to me in those early days to start building as soon as possible. So I want to point out something in this, which is rule learning, number 7. I want to highlight this. Because rule learning is hugely important in building models of the world, and it's the primary way that a beginner starts to develop patterns and expectations of their reality. So you need to give people opportunities to learn the rules of the game over the course of many instances. And it was helpful for me when I was first learning about incidents and monitoring to have other members of the team constantly vocalize their actions and the reasoning that they had behind those actions, so lots of oral presentation. Repetition gave me the building blocks for discovering patterns in the operations world. And having this rapid feedback and rationale for why the world was the way it was granted me inroads to knowledge. So when information is transparent and available within your systems and organization, beginners can succeed. So once we've laid the groundwork for learning, scoping out our path, and kind of understanding that we need lots of stimulus and response at first, and trial and error, we can do the actual work of learning. And this is a lot of work, but it's also a ton of fun, at least in my opinion. And for that, we need to go back to a lot of our least favorite methods of learning. Is this meme not outdated yet? I'm always like 2 meme cycles behind, but I used to think that the path to success in learning was studying by just rereading material. And I did pretty well on tests throughout school with this strategy because I had a lot of confidence that I understood the material. This is what learning science calls the illusion of knowing, and why, although I made like 500 concept cards for my AP US history class and memorized all of them, that a month later I couldn't remember any of those subjects. So going back to documentation or going back to the textbooks has been shown to be largely ineffective in storing something in long-term memory. And storing and linking concepts in long-term memory is necessary for that expert intuition that my coworker had when he made that recognition at the beginning. So what do scientists say we should do in order to embed knowledge in our long-term memory? So their first piece of advice is to test yourself often in low-stakes environments. So low-stakes testing is the frequent use of evaluation instruments over the course of learning something new. So every time when I'm working, if there's a word or a phrase I don't understand, I write down that explanation or definition on one side of a card, and I write a question on the other. I look at these cards daily and ask myself that question, and I try to refuse to turn over the card until I have some sort of guess at what the answer is. I found that over time, this testing reduced my need to go back to the docs and re-look up information, and increased my confidence during incidents and the knowledge of concepts I had learned in the past. So why is low-stakes testing so effective? It's because in order for our brains to learn, we need to practice retrieval. And retrieval requires a bit of effort. So this active retrieval strengthens the neural networks that hold our memories, allowing these memories to be more easily accessed in the future. So this is like building a hash map with the neural pathways in your brain. So a little bit of a controversial statement, but this is one rule that I keep for myself whenever I'm looking for like a method name I don't remember or a concept that I'm trying to reach for. I don't Google it first, with the caveat of yet. Obviously, sometimes I do need to Google things. But trying to think about a solution before I just immediately look it up really helps me retain information better for the future and recall it much easier in moments of stress. So while any sort of retrieval practice is useful, it's more beneficial when it's effortful. And this is because that strain makes those pathways even stronger. And there are 2 known ways that I've used to make learning even harder on myself. And that's delayed retrieval and interleaving. So delayed retrieval is just temporal spacing between your retrieval practice, and interleaving is not working on any one problem for too long. And a method that I've used to practice both of these comes from the German learning scientist Sebastian Leitner, with the cover of a book that I think this is like the worst cover of any book, but also very apt for like a German learning scientist. So he developed something called the Leitner method, and it's the idea that you take 3 boxes or more of cards, and the cards in box 1 are cards that you've made a lot of mistakes with. 2, you have more familiarity. 3, you're pretty certain you know. And you only study the cards in box 1 box 1 you want to do every day, box 2 maybe every week, box 3 every couple of weeks, and then you promote and demote the cards as you get them right. So this embraces both delayed retrieval and interleaving, and I actually keep these boxes just at my desk, and anytime a new piece of information comes in, I just throw it in box 1. So I use these for concepts like, in the beginning I was doing HTTP status codes, Linux namespaces, errors that I come across, methods in different programming languages. All these things made me immensely faster at reacting to outages. Even if I didn't completely understand the story of the incident, I had enough information to just start debugging. So once I had the basics of retrieval down, I wanted to try more advanced memorization techniques. So I turned to something called memory palaces. A memory palace is an imaginary location in your mind where you store mnemonic images. So you take something that's super bizarre and not meant to be in that place, you put it in that place and pair it with different concepts. The organization Sketchy Medical has helped countless medical school students with their bizarre and memorable visual elements paired with medicine topics. They don't have these for computer science, so I had to make them. I built memory palaces in my living room to remember different aspects of protocols. I kept a conversation between two tarantulas using the tarantula communication protocol to remember, to remember different aspects of TCP. Memory palaces are an awesome bridge from the route memorization of my Lightner boxes involved in low-stakes testing to the true powerhouse of expert intuition, which is stories. This brings us to how we move from general knowledge that we've gained to start building abstractions of that knowledge into models. So, mental models. These are created in the process of turning patterns and events into abstractions and stories, and are the basis of expert intuition. So, by way of explanation, let's consider the frillfin goby, one of my favorite fish. The frillfin gobies are our mental model mascots. So they're these fish that live in rock pools where birds are their biggest predators. And scientists have observed that in order to protect themselves, when birds attack, they have the power to fling their bodies out of a rock pool into a neighboring pool. And scientists were pretty impressed by this because they do it with near 100% accuracy. So they decided to study them. And it turns out that at high tide, these fish make maps of the entire ecosystem of rock pools and store those mental maps for when something stressful is happening, like a bird attack. So the next time that your pager goes off at 3 a.m. and a decision needs to be made about switching over regions or making a jump from a fish attacking your system, mental models are gonna have you prepared. So that's a really helpful way to think about them. Try to be like the frillfin goby. So beyond giving us abstractions and maps of our systems, these mental models make us better storytellers, and in turn, competent in detecting when something in our system doesn't match that story. When we move beyond our experiences with system A or system B to a story about how a healthy system is supposed to react and work, we become much better at automatically realizing when there is a problem. So how do we build mental models as good as the frillfin goby? The first step is realizing that they're incredibly difficult to develop and may take many years of practice, and not to be too hard on ourselves when we don't have these stories immediately. And this is because understanding structure is hard. We move from events and patterns to develop structure. And we do this by mentally filing away a massive but finite amount of fundamental knowledge that can be used in evaluating an infinite amount of scenarios in the real world. So very slowly, through patterns, we build abstractions. And something really important to notice here is that if these events and patterns are incomplete or faulty, the abstractions and structure that you build on top of them will be also. This is why I have built all of my mental models off of observability. So to me, observability is just the idea that everything should be understandable and discoverable. My definition of observability comes from the principle of observability in general science. And this is the idea for every input to a system, there must be an observable output. So for me, this sense goes beyond just instrumentation of the code to documentation and historiography. The historical context around why any feature is implemented is just as much an input to your system as the data that you feed it. So observability makes our systems more hospitable to learners. And if I were going to look at a new system, a new service, a new app that I'd never seen before, and I wanted to tell how observable it was, I'd ask how long it takes to onboard new engineers, to give them complete information and have them start to make structure out of it. How long would you expect a new engineer to work on your service or app before they could go on call for it? So after observability, regular reflection over my first years in ops really helped me build mental models faster. Reflection is critical to sustaining memory and building mental models because it takes a lot of the cognitive activities that are scientifically proven to lead to stronger learning. So researchers at Harvard Business School have conducted studies on the relative impact for different types of learning and discovered that at a certain point there are diminishing marginal returns to additional experience compared to the benefit of deliberately codifying your past experience. So if you're trying to level up faster and you just don't have the time to gain as much experience as your teammates, practicing active reflection is going to get you there faster. So for this reason, in my first year, and whenever I join a new team, I take the responsibility of running incident and project reviews at every opportunity, which lots of senior engineers will gladly give me that, right? So if I didn't completely understand the context of an incident when it was happening, this always gives me an excuse to interrogate engineers for why they perform certain actions after the fact. So these practices help me make up what I lacked in experience. And so I would say to any managers in the room that all of these incident reviews need to be designed, centering the less experienced members of your team and their questions. So once we have good mental models built through observability and reflection, we can improve on these by extending them to more explicit models. An example people often cite is learning both an object-oriented and functional programming language, and I can attest this was really helpful for me. When one feels they're gaining competency in OOP and wants to deepen their understanding of concepts like scope and membership, removing them in favor of language attributes in functional programming can emphasize their true importance. So in my humble opinion, everyone knows it's humble? Not, okay. This is the point at which I start to hold any opinions, although I think most people feel opinions precedes all of this understanding. So using these tools to cement my own learning and understanding really works for me, but I don't work alone. I work on a team. So how can I leverage my team to support me in this learning? So learning together is what Nora Bateson calls semathecy, and this is really how we discuss systems of understanding and how they live together. So what are some of the ways we can bring semathecy, or these living systems learning and growing together, into our organizations? So first, I want to shout out my favorite feature on the observability platform, Honeycomb. And this actually has little to do with what's being instrumented in our code. It's a feature they have for collaborative debugging with your teammates. And this gives all developers on the team a way to understand and share what's going on in the system by sharing the queries that other engineers have run. And this shares what the senior developers on the team understand implicitly and just makes that explicit for everyone. So everything is visible in your system when you do this, and including the thought processes that go into it, which I think is really wonderful. The next way that we can support semathecy is through cultural memory. So to talk about cultural memory, I want to take us on a quick tangent back into the animal kingdom, and I want to talk about elephants. So in the 1990s, a severe drought hit Tanzania, and this resulted in the death of 20% of the African elephant calf population. That population is part of 21 different families. Each of them is led by a matriarch, and they're divided into 3 clans. Researchers studying these elephants analyzed the survival of the calves and found that families led by the older matriarchs had fewer deaths during that drought. So they also saw that 2 of the clans had actually left the park in search for watering holes that they hadn't gone to in over 60 years. So those elephants that were old enough to remember the last worst drought had shared that information with the rest of the pack, leading to higher survival rates. Elephants have to pass this information through experience, but us humans have a really special advantage in that we can just tell each other. So think about the worst outage that you've ever faced on your team. Are you thinking about it? Are you in a dark place? So this incident left a mark on your memory and the memory of your team that someone coming in who doesn't have that experience or memory isn't going to know about. And the way you monitor and operate your systems is built on top of those bad memories, and a newcomer to that system isn't going to know why. So when I first started at BuzzFeed, they told me this story about Hurricane Sandy and how they had to switch over to a cloud provider overnight. This impacted, obviously, a lot of design decisions, and some of the infrastructure we still have today was built out of that path and is dependent on it. Knowing this story and having this information makes me better understand the infrastructure than if they hadn't told this to me. This is why institutional knowledge is hugely important. And when a new person joins the team, we need to make sure that they have that knowledge. So a memory tool within my team that's been essential for helping me grow, and I talked about last year, and I just want to emphasize again, is having and working with people who have a growth mindset. So there's a 2010 study that was done on fifth graders by the researcher Carol Dweck, where she put fifth graders into two groups and gave them a puzzle. The first group, when they did well on the puzzle, she told them they did well because they're smart. And the second group, when they did well on the puzzle, she said, you did well because you worked really hard. Then she gave them another, much more challenging puzzle. The kids in the group who were told that they do well because they were smart gave up on this puzzle very early in. But kids who were told that they did well because they worked hard did significantly better and got further. This is her finding from that study. Emphasizing natural intelligence takes it out of the child's control and provides no good recipe for responding to failure, if we replace child with software engineer. Learning requires a lot of failure, and no matter how smart you are or you think you are, you will come up against problems eventually that stump you. It feels much better to have a team that believes you can work through those problems. So growth mindset is a great foundational tool for a team to promote healthy learning, but there's one final tool I want to discuss before I end, and that's psychological safety. Psychological safety is a shared belief on a team that you're safe to express yourself and that you're safe to ask any questions that you may perceive to be naive. I hope through this presentation I've shown you the benefits to improving your memory so you can quickly gain better understanding of your systems, but memory goes beyond your work. Many studies have shown the links between memory and mental health, and that when our mental health suffers, so does our ability to retain strong ties between concepts and our mind. So we need to feel that we're on a team and in an environment that's oriented around solving tough problems, but that it is not a place that cares first and foremost about blame. And that oftentimes outages and incidents in moments of stress surface emergent properties about systems, but not about the people who build them. If you're not in a place where you can sustain good mental health, your memory will suffer, and if your memory suffers, so will your team's ability to respond to incidents. So looking back at that first outage and looking at myself now, I have no fear of incidents anymore. In fact, they are singularly the favorite part of my job. Optimizing for learning has made me a better engineer, but more than that, it's forced me to look at systems in a way that is very human. So in summary, prepare, use constraint satisfaction problems, lean on hierarchies of learning by working with stimulus and response first before you start solving problems. Low stakes test yourself, practice retrieval, delay and interleave, use the Lightner boxes, they're really handy to have at your desk, and build memory palaces, they're super fun, and share them with me. Abstract by building Frilf and Gobi level mental models, moving from events and patterns to structure, observe and reflect, and get experience with different types of systems. And embrace your cultural memory of your teams, share those worst outages with each other, have a growth mindset, and finally, build psychologically safe workspaces. Thank you for your time.